Hey there, physics people. This is Mr. Clegg. Now, I want to add the second video on this packet here because I really want to explain the idea of what it is. Why can you take the area of the velocity time graph and why is that the displacement? Um, Maybe I won't exactly answer the why question, but I think you'll start to see how it works. First of all, we already saw that on this little area right here, if we have the area under this part is 6, right? So we have 3 times 2. So that's 6. And that ends up being meters per second here and meters per second here and seconds here. So meters per second times seconds gives us units of just meters because the seconds cancel out. So this would be, right? I'm going to erase that. In here, the area of this is 6 meters, right? And so that corresponds to, I went from 0, I went 6 meters in that amount of time, right? Now this might seem a little weird, like, well, why did we go to 2 seconds? Well, let's go to 1 second instead. I'm going to chop this in half. So I'm going to put a line right there, and I'm just going to say, let's just go for 1 second. How much area do we have here? Well, that's 1, 2, 3, right? So that's an area of 3 meters. 3 meters per second times 1 second is 3 meters. So that means in that 1 second, right, we went from here, we went up 3 meters. So in that 1 second, we went 3 meters. The area down here is 3 meters. Okay. Let's do it again. Let's do for half a second, okay? Let's just do half a second. Okay, this is a little tricky, but what's the area over here on the left? What's that area for half a second? So it's 3, right? And then times a half. So it'd be 3 halves, which is 1.5. And so in the first half a second, how far did we go? We went 1.5 meters, right? So we went 1.5 meters. So it doesn't matter what you choose. Oops, let me see if I can do this. There we go. So the next thing, and also what's the area under here? The area under that part from 2 to 7 seconds is 0. There's nothing under there. And so we didn't go any farther after that. We didn't have any more displacement. You can do this along anything you want. You could say, okay, well, let's do a negative one. Okay, let's just do the first second right here. Let's say for this first second, right, we have -2 displacement because at -2 times 1, -2 right there. Okay, we got -2. That means that from here to here, we went backwards by 2. We went from 6 down to 4. That's a -2 displacement. If we went for 2 seconds, we got 4. And so for the 2 seconds, we went from 6 to 2. That's a -4 displacement. So again, -4, because this is down below. And then, right, and then we went down. We went negative displacement of -4. Now we have a positive. Let's do just this one. We have 1 from 2 to 3, 1 meter. So from 2 to 3, we went 1 meter. From 2 to 4, we have 2 meters. From 2 to 4, we went 2 meters, right? We went 2 meters. Okay, so I'm trying to show that is no matter how small or big of a time interval you choose, right? Here we have, anyway, so I think I've made that point. Hopefully that is good. Oh, we could even do that here. Check this out. Let's do it for one of these. Okay, so let's do the first second. We have 2, right? And then up in here we went 2 meters in the first second. What if we went for 2 meters? We have 4. Or sorry, 2 seconds. We have 4. So in the first 2 seconds, we went 4 meters. We went from 1 to 5. We went 4 meters. So hopefully this makes sense that you can really see some of these examples. Let's say from 2 to 4 seconds, how far did we go? So from 2 to 4 seconds, it's a little bit of a fat line, but you can see hopefully that's exactly in the middle. So that's an area of 1, right? So from 2 to 4 seconds, we have half of these 2 squares. So that's 1 square. And so from 2 to 4 seconds, look at that. We went 1 meter forward in the positive direction. We went from 3 to 4. We went 1 meter. And then, okay, what about the backwards ones? What about these negative ones? Here we go from 4 to 6 seconds. You have half of those two squares, right? So we have -1. We have -1 meter. And from 4 to 6 seconds, we went from 4 meters down to 3 meters. So we went -1. All right, so hopefully you can really see how these match up. Now, this only works when you've drawn your graphs correctly, but when you've drawn them correctly, they match up like that perfectly, and it always works. So what's the acceleration between 2 and 5 seconds? 2 to 5 seconds here, that would be the acceleration is the slope of your velocity time graph. That's 0, right? So slope, is the acceleration, is the change of velocity over time, right? And that is 0 meters per second squared between 2 and 5 seconds, right? What's the total displacement? Let's take a look. Now here again, we're going to take the total displacement between the 0 line, right, between the axis and the curve, right? So we're taking this part. There's nothing in between here. And then here, we'll do a different color. Here we have the positive one. So this is, right? So let's add up both of those areas. Well, this one's negative, right? So this one here is positive. So we've got 1 and then 2. So this is 2. It's half of 4 because it's it's 2 by 2. Then you take half of it. So that's 2. Okay, that's 2. And then here we have a negative. And so -2, right? So they actually add up. -2 plus -2 meters plus 2 meters adds up to 0. So we have 0 net displacement in this whole thing. Make a displacement graph. So I don't have enough space to really make this work. We are moving in the negative direction, right? So we have -2 and we have a curve. So basically we're starting out at the purple side of here. We're moving in the negative direction with a curve. Now we have, this is my displacement up here, negative, then it's 0 because we have no velocity. And then we're going back in the positive direction. And so now we're going back up here. And between both of those, we ended up back at our start point. And I know that we ended up back at our start point because our displacement is 0. So whichever displacement we went down, let's just make up a number we don't really know from this graph. But let's say if this was 6 meters and this might be 4, then we went back up from 4 to 6. I know that it's 2 because I know we went back 2 meters, and then we went forward 2 meters, right? So I know I just sort of crammed that in there. Hopefully that's helpful to you, even though I just sort of jammed that in there at the end and don't have enough space really for it. Okay, during which time interval is this moving in the negative direction? I'll stay with orange. Looks like we're not moving, and then after 4 seconds, we're moving. So after 4 seconds. Right. What is the total displacement represented in this graph? Again, we're going to take 0. We're going to take the space between the axis, and I'm going to color this differently so you can see how I'm counting it differently, right? Right. So we're going to add up all this area. So it looks like we have 1 plus 4. So that would be 1 plus 4. I should make this one orange. The total would be 5. Okay. All right. Now, what's the significance of the point at 6 seconds? Super important that you realize this is where it turns around. If this had been a position time graph, then this would be the turnaround point because it's going one way, then it turns around and goes the other way. That's not the case. This is a velocity graph. So what's happening is this is not moving. It starts to move in the forward direction, right? Look, anything up here on this side, right? Anything that's positive like that is in the forward direction, right? All of this up here is positive, and all of this down here is negative. That's in the negative direction, in the backward direction. So here's what's happening. It's starting, it's not moving. At 3 seconds, it starts moving forward slowly, faster, 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 fastest, still moving forward, starting to slow down, still moving forward, slowing down, still moving forward, slowing down, stops, starts moving backward, faster, faster, faster. So that's what's happening. All right. I'm going to pause the video while I write what I just said. Okay. This is what I wrote. Yeah, I'll just leave that. Actually, pause the video if you want to read it more, because I don't want to make the video too long. All right. Describe the motion between 0 and 6 seconds. Same idea. From 0 to 4, moving backward, speed decreasing. From 4 to 6, moving forward, speed increasing. Okay, what's the total displacement represented in the graph? All right, we're going to add up the one that's negative here. So we got negative displacement here. This is an object that's moving in the negative direction or in the backward direction. And we can add it up to 2 times 4, but half of that. So it's half of 2 times 4, which is 4 meters. Let's do another color for this part here where we're going forward. That's half of 1 times 2, which is 1. Oops, I forgot to put the negative sign. There we go. Okay. And now we'll do a different color here. Now we just have one more. So we're adding one more. So if you add all that up together, you should get -2 meters. Describe the motion between 0 and 6 seconds. All right, here we go. I guess you guys are probably really good at this by now. Pause the video now. See if you can do it. Okay, now we'll do the displacement. Here we go. Positive. I'll use orange, I guess. Oops, come on. There. So we have this. We got a positive displacement here. So we have 3 by 3, half of that, 4.5 plus, right? 4.5 meters. Now we've got this negative. Looks like negative, same thing. So this would be minus 4.5. And then it looks like we have a little bit more here. Maybe we'll have to do like a little blue here. Let's do that. That's half of 2, which is 1, minus 1, because it's still negative. And then we have another little guy here that looks like another 1 here. Another 1. Okay, all of that, minus 1 meter. So it looks like we have the 4.5 and negative 4.5 cancel out. We have minus 1, minus 1. So the total ends up being -2 meters. That's our answer for the whole thing, -2 meters. All right. Good luck, everybody. I hope this helped. See you in the next one.